Yes, dear friends, today in this topic, in this video, here the topic is electric field due to spherical charge distribution. Actually, it is for the knowledge of physics here, and what we have learnt about Gauss theorem. This is an application of Gauss theorem again. Actually, some people are exploiting in the name of syllabus that this is not in syllabus. But Gauss theorem is in syllabus, and anywhere you go for competitive exam, you may be asked, because we can't say we can't apply Gauss theorem within a particular topic. We can apply anywhere else. I will be telling you so many things are there which have been deleted, but we are using every day. So it is our duty to understand the subject. So here, what is there? It is a sphere. Don't think a conducting sphere. Simply it is charge inside a sphere of radius capital R, like the charge is filled in the nucleus of atom. Then how the field will be determined at any point P outside the sphere. I mean, here is the point P. It is Gaussian. It is the area element of Gaussian surface. Here Gaussian surface will be a sphere of radius small r. Capital R is the radius of distribution. So here figure shows a sphere of radius r which is filled with charge distribution, which is distributed uniformly such that its volume charge density is equal to rho coulomb per meter cube. So total charge inside the sphere Q is equal to rho into 4 upon 3 pi r cube. What is this 4 by 3 pi r cube? Volume of the sphere under consideration. By rho coulomb per meter cube means in 1 meter cube charge in rho coulomb. So in 4 by 3 pi r volume this. Now to find electric field at point P, we consider, please write yourself, to find electric field at point P, we consider this Gaussian surface as a sphere of radius small r from Gauss theorem. Gauss's theorem. Integration for closed surface E dot ds is equal to total charge Q upon epsilon 0 is equal to rho into 4 upon 3 pi r cube upon epsilon 0. At every point of the Gaussian surface, vector E and ds are parallel. Vector E parallel to ds at every point of Gaussian surface here. So we can write integration as E ds cos 01 is equal to Q upon epsilon 0 equal to rho into 4 pi r cube upon 3 epsilon 0. At every point of Gaussian surface, magnitude of electric field remains same. So we can write this as integration ds is equal to Q upon epsilon 0 is equal to rho into 4 pi r q upon 3 epsilon 0, and it is E into 4 pi r square. What is this? Total surface area of this Gaussian surface, which is again a sphere. Surface area of sphere is 4 pi r square. Please learn mensuration also. Actually, fundamental mathematics are there, which you should remain with you in your brain. Keep on working hard. Is equal to q upon epsilon 0 or rho into 4 pi r cube upon 3 epsilon 0. Now, using these are the same thing, or we can write k E is equal to 1 upon 4 pi epsilon 0 q upon r square, using these two. And if we use this and this, or E is equal to this 4 pi cancel, we get rho r cube upon 3 epsilon 0 r square. Rho, charge density. This equation and this are the same. But here charge, if we put a value of charge rho, if we put the value of rho in terms of charge, we get this thing. So these two equations can also be written in vector format. I should have written here, but the student confused, so we write separately. This equation vector E is equal to 1 upon 4 pi epsilon 0 q. I write here r cap upon r square, or E is equal to, vector E is equal to rho into r cube vector r cap upon 3 epsilon 0 r square. Here r cap is a unit vector pointing from O to P. P may be here, may be here. So direction r cap, you can take n cap. I take here just for one formality here. So this is the electric field at any point outside. If point P lies on the surface of the sphere, on the surface of sphere, then small r equal to capital R can be used in equation 1 and 2. In equation 1 and 2 here, we can write small r equal to capital R, and hence vector E equal to 1 upon 4 pi epsilon 0 q r cap upon r square. If point P is here, equation 3, or you can write it as E equal to, in terms of balance, 1 upon 4, rho into r cube, r square, यहाँ तो only r is left, and r cap upon 3 epsilon 0. R cap is unit vector along R. Point चाहे यहाँ हो, चाहे यहाँ हो. Where is the point? I have told you, and I keep on telling, a unit vector A is the unit vector which has magnitude only 1, and if A is the unit vector along direction of A, then A is equal to vector A upon modulus A. Or you can write A upon A. So vector A is equal to A into A cap. So here vector r cap into r, it becomes rho r vector upon 3 epsilon 0. This is the electric field at any point on the surface in terms of position vector r. R is this point where if you go this way, then R will point this way. So equation 3 or 4. Here 3 is in terms of total charge, Q here is in terms of charge density. And this expression is very important. Actually, people ask those questions which students don't study. Either they ask very fundamental or at last. Now come to the point. Equation 3 and 4 are the same. Equation 3 and 4 are the same equation. If point P is inside the sphere, that is R less than capital R. Then we imagine again Gaussian surface here. Point P now here. This is R is this. Then using equation 4 we can write it directly as rho r upon vector r upon 3 epsilon 0. But let us explain in terms of Gauss theorem. At P here, integration E into, now you understand, 4 pi r square, area of the sphere, equal to total charge inside. So whole charge will distribute inside this. Here if it is charge Q dash, so Q dash upon epsilon 0. But Q dash is equal to rho into 4 upon 3 pi r cube. Don't you agree with me? Where rho is the volume charge density, total, and charge density constant throughout. So volume of the sphere multiplied by charge density is this. But it is Q upon 4 by 3 pi r cube also, into 4 by 3 pi r cube. So 4 by 3, okay? So you can get here 1 upon epsilon 0 into Q dash, QR upon QR cube upon R cube. E into 4 pi r square is this. So what is R? What is R here? I mean small r, cancel. So you will get it E equal to 1 upon 4 pi epsilon 0 r q r upon r cube. Perfectly, I have written this equation because we need it to explain certain facts. Okay? But now, in terms of charge density, I told you that Q is equal to 4 by 3 pi r cube into rho. So if I write here Q is this, then what will be E? E equal to 1 upon 4 pi epsilon 0 and 4 upon 3 pi r cube into r upon r cube. So 4 pi cancel and we get it as, sorry, rho should go away, rho into r. So we get it as rho r upon 3 epsilon 0. And so in vector form, we can write it as vector E equal to 1 rho upon 3 epsilon 0 vector r. If point P is inside, wherever it is, here or here, then electric field in terms of position vector of point P with respect to center of the sphere. So here I have derived the formula for electric field due to charge sphere, and you have to remember them. First of all, 1 upon 4 pi epsilon 0 q upon r square at this point also. It is also equal to क्या भाई rho into if I write q is equal to 4 upon 3 pi r cube into rho upon r square. So it will be there rho r upon 3 epsilon 0 r square. एक ही चीज है. At surface E equal to 1 upon 4 pi epsilon 0 q upon r square, or E equal to 1 upon 3 epsilon 0 rho into r. In vector form, E equal to rho upon 3 epsilon 0 vector r also. And these are electric field at inside. Now, why this expression is important? Generally, you may be asked the graph, and this is again important to explain a question here. If I plot the graph between distance r from center and electric field, so till point is inside, in r less than r, so this thing remains constant. So electric field varies here. If I take r and E, electric field varies up to when r equal to r, and become how much? Become this thing here, or this one. कितना? 1 upon 4 pi epsilon 0 q by r square, and then start decreasing. Generally, I have seen in many exams question based on this. So it was all about electric field due to charge distributed inside sphere. I will take some questions just now in next video on this topic, just to explain you it more clearly. Thank you.